This is a continuation of the 6.4, 6.5 notes. So we're on the back side talking about rhombi. So first we have the diagonal of a rhombus. If a parallelogram is a rhombus, then its diagonals are going to be perpendicular to each other. So we talked about parallelograms and some of their properties, but what makes a rhombus special is that these diagonals, which are the lines that are going across, they're going to intersect at 90-degree angles. So this is a 90-degree angle here, and we can do the same all the way around. So all four of those intersections are going to be 90-degree angles. So here I could say that the line AC is perpendicular. Remember, the upside down T is one way I can say perpendicular to the segment B. Oops, that's a D. BD. Okay, so the diagonals are perpendicular to each other. Next, we have all sides of a rhombus are congruent. Okay, so that means that they are equal to each other. They have the same measurement. So if this is 10, this is 10, and they are all 10. Okay, all sides in a rhombus are congruent. If a parallelogram is a rhombus, then each diagonal will be bisecting the pair of opposite angles. Okay, so they're going to cross each other, connect at 90 degrees, and then also they're going to come through and bisect the angle. So if angle 1, for example, was 30 degrees, angle 2 would also be 30 degrees. They bisect each other, okay? And because this is a type of parallelogram, that would mean that this is also 30 degrees and this is also 30 degrees. So you're still following the same how to find the angle measurements of a parallelogram. Remember, parallelogram really is an extension of these parallel lines where the consecutive angles, this one and this one, would add up to 180. So if I'm using this example, 30 and 30 would give me 60. So if I asked you to find this missing angle here, I would subtract 60 from 180 and get 120. Okay? And then again, if I'm talking about a rhombus specifically, these had to add up to 120. That means each of them would be 60 and 60 because they're cutting each other in half. Going on to example 4 here, we have a rhombus. We have RK is 3, so this right here is 3. RY is 5. And I am looking for KY, so I'm looking for this right here. Okay. Something to mention is that these intersect at a 90-degree angle again. So really what we have is a right triangle. We haven't seen a right triangle yet, but hopefully you remember a few things. If I'm looking across the 90-degree angle, that's where the 5 is. And then at the bottom here I have the 3. And then this is what we are looking for, right? We're looking for KY. I'm just going to call it X. Think about all the previous knowledge you know of geometry and shapes and triangles. There's a special formula we can use when we're finding the missing side of a right triangle, and that's called the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. The only one that really matters here is c squared, because it's always across your 90-degree angle. So in this case, our C value is 5. So I have 5 squared. A and B don't really matter. So I'm going to call this one A, the 3, and then B is going to just be my missing side, which is X. So in order to do this, I'm going to start by subtracting 3 squared from both sides. Now, one of the biggest mistakes we see in this type of problem is that students will want to subtract 5 minus 3. And that's not the case. This is 5 squared minus 3 squared, which you should do in your calculator. So if you type in 5 and then the x squared button, and then minus 3 and then the x squared button, that's going to give you, the calculator is going to do the math for you. That's 25 minus 9, which gives you 16. If you're not getting 16, you're putting it in wrong, so try it again. If you're not quite sure what you're doing wrong, just type in 5 squared. Again, that's going to give you 25. 3 squared is going to give you 9. And 25 minus 9, that's how I get the 16. Okay? Now, I'm almost done solving for x, except this is an x squared. So thinking about how I get rid of a squared, I want to square root both sides. When I square root both sides, I end up with just x on the left and then positive 4 on the right. So there it is. I found the missing side. ky comes out to be 4. So this is one of the more difficult problems. And again, I'm able to use the Pythagorean theorem because these diagonals intersected in the middle at a 90-degree angle. And I can use the Pythagorean theorem anytime I'm dealing with a 90-degree angle. That's how I'm finding the missing sides. Hopefully on a test, we'll ask you for an easier type of question. So if, for example, if I have PZ, I could find PZ because that's 5. I could also ask you for RP, for example. If it's a rhombus, all sides are equal, so without doing any math. That's also 5, and this is also 5, okay? So know the different properties of a rhombus because sometimes it won't be as complicated. And the last example here we have the diagonals of W, X, Y, Z intersect at V, so that's in the middle. If angle WZX is 39.5, so W to Z to X, that means we start here, go down, and then up towards X. This angle right here is 39.5. I want to find angle ZYX, so from here to Y up to X, so I want to figure out this whole angle. And then I'm going to come back to the diagonals here in a second. Okay, so finding this angle first. My first task, because this is a rhombus, I have to remember that in a rhombus, the diagonals bisect each other. So without doing any math, I know that if this is 39.5, then this is also 39.5 because they're cutting each other in half in a rhombus. That's what makes a rhombus special. Okay, so then the opposite sides are also going to be 39.5 and 39.5. Well, it's probably useful for me to figure out what the whole thing is. Okay, so if I do 39.5 plus 39.5, adding them up, I end up with 79 degrees. So if I'm looking for this bottom angle, I remember that these are sets of parallel lines. Okay, and so the consecutive angles, this one and this one, they should add up to 180. So 180 minus the 79 I already know gives me 101 degrees. So this angle that I was looking for, the measure of angle ZYX, is 101 degrees. So you have to use the knowledge that the diagonals are bisecting the opposite angle as well as the consecutive angles adding up to 180 that we learned from a previous section in parallelograms. That's how I can figure out the missing angle. Okay. Now the last piece, I'm going to erase this so we can label what we have. We have WX, which is up here. That's 8x minus 5. And then WZ, which is on the side, 6x plus 3. Now, because this is a rhombus, I know that all sides are congruent. So this one, I'm just going to set them equal to each other. So 6x plus 3 equals 8x minus 5. And I can start off by subtracting 6x from both sides. 3 equals 2x minus 5. Then I can add 5 to the left, so it cancels out on the right. 8 equals 2x, divide by 2, so x comes out to be 4. Okay, so that's how we solve for those measurements. If the test was specifically asking you for the measure of WZ, for example, you would take the x, plug it in, and get your answer. So just kind of read the question, make sure you're answering the entire thing. Now, this table at the very end kind of sums it all up for us. So we have, what makes them special. These are all parallelograms. Rectangles, we talked about the first part of these notes. They have 90 degrees in their, each angle is 90 degrees. Rhombi, we have all sides are equal. And if I put a rhombus and a rectangle together, they make a square. So a square has the properties of both a rectangle and a rhombus. It has 4 equal sides, and it has those 90-degree angles. Okay, so these are all the properties kind of put together. A square is a special type of rectangle and rhombus together. And that is the end of our notes.